Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over question number 4 of the 2019 AP Calculus AB free response questions. This will be focusing on related rates and differential equations. All right, so question number 4a will be focusing on how to solve related rates problems. So considering this figure right here, question 4 reads, a cylindrical barrel with a diameter of 2 feet contains collected rainwater, as shown in the figure above. The water drains out through a valve not shown at the bottom of the barrel. The rate of change of the height of the water in the barrel with respect to time is modeled by the HDT equals negative 1/10 root h, where h is measured in feet and t measured in seconds. The volume of the cylinder with a radius r and height h is v equals pi r squared times height. Question 4a. Find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. Indicate units of measure. All right, before we get started, there are certain things that you will have to keep in mind, okay? So some things to note for problems like this. For differential related rates problems, you're going to be differentiating implicitly, okay? So first thing to note is what to do when you're differentiating implicitly, which is as follows. When I'm differentiating implicitly, you always want to make sure that you check for agreement, okay? We're going to go over this in more detail when we are solving the problem. Remember to check for agreement. And secondly, how do you know that this is a related rates problem? Well, related rates problems involve what? Involves differentiation with respect to time. Differentiation or rates of change with respect to time. Okay, so if you take a look at the problem, do you see how we can tell that this is a related rates problem? Notice what's given here, the HDT, that's the rate of change of height with respect to time. We're asked to find the rate of change of volume of water in the barrel. Okay, and everything, the changes here are expressed with respect to times. Okay, all right, so that's something to keep in mind. Now, let's go over the steps involved in solving related rates problems specifically. All right, so the steps for solving related rates problems are as follows. So first of all, you want to identify the formula that connects related rates, that connects the related rates. And then after you identify the formula that connects the related rates, you basically differentiate it with respect to time, okay? And then you differentiate it with respect to time, Don't forget to check for agreement. When you're dealing with related rate differentiation, there's going to be disagreement with every variable, so that's just something to keep in mind, all right? And then when you're done differentiating with respect to time, you're going to list your known and unknowns. List your known and unknown, and then after that you're good to go. It now becomes an algebra problem, okay? So when you list your known and your unknown, lastly you just substitute and solve. So step number 4, you substitute and solve, okay? Substitute and solve. All right, let's go ahead and do it. All right, so first of all, let's go ahead and identify the formula that relates the rate that we're dealing with here. So you might say, what rates are we looking at? Well, we're looking at rate of change of volume, and we're given rate of change of height, dH dt. Okay, so what formula relates volume and height? Well, they gave us a formula, and they also gave us the solid that's under consideration. Sometimes they'll give you the formula, sometimes they do not. In this particular case, we're given the formula, so that makes our life much easier. So the formula is volume equals pi r square h. So when we differentiate this formula with respect to time, we get to see how the rates relate to each other. Okay? All right, so the problem asks us to find the rate of change of the volume. So what on earth is rate of change? What does that mean? So rate of change of volume, rate of change of volume when h is equal to, what was the height equal to again? I think it was 4. Yeah, when height was equal to 4, what does this mean? Well, let's go ahead and write down Navier-Stiller real quick. All right, so what does R and Navier-Stiller mean? We know that R means rate of change. Okay, rate of change and derivatives are the same. So when they're asking you to find the rate of change of the volume when h is equal to 4, we're looking for the derivative of the volume with respect to time evaluated when h is equal to 4. Okay, so basically this is the same thing as dv dt evaluated at h equals 4. This is going to be a two-part process. We're going to break it up. The first thing we're going to do is we're going to find the expression for dv dt, the related rates equation, and then we're going to evaluate it at evaluate the v dt at h equals 4. Okay, so those are the two parts involved in this process. All right, so let's do it. So we'll start with the formula. V is equal to pi r square h. So what we're doing is we're going to differentiate with respect to time, the entire equation. Okay, so now we're talking about checking for agreement. We differentiate with respect to time. So any term that is a time term, there'll be agreement, and that term will not have a differential associated with it. Okay, but you notice v, r, and h, these variables are different from this, so you're going to have d of that variable dt using the chain rule when you're differentiating that term. Alrighty, let's do it. So if you differentiate volume, you're going to have 1 times, using the chain rule, dv dt because of this agreement. Okay, that equals the derivative with respect to time of, let's group these as pi r square times h. I'll tell you why in a second. Okay, so you notice how I set this up? I have a product of two variables right here, so I have this set up so I can use the product rule. Okay, so this will be u and this will be v, and we're going to differentiate this. Okay, so if we differentiate this using this product rule, we're going to have vu prime plus uv prime. And then we want to make sure that we keep track of agreement and disagreement. So let's do it. So v is h. U prime, derivative of pi r square, is going to be 2 pi r. To check what, I should have written it the other way. Let's do pi r times 2r. Pi times 2r is correct, but I just want to show you. So pi is a constant, and if you differentiate r square, you get 2r, and then you add on the r dt because of this agreement. Okay, plus, so this is vu prime plus u is pi r square. V prime, derivative of h is 1. We have this agreement there, so we're going to add the h dt. Okay, all right, so let's make it look pretty. dv dt, derivative of the volume with respect to time, or the rate of change of the volume at any time. is going to be 2 pi r h dr dt plus pi r square dh dt. All right, there you have it. All right, so now we're going to proceed to the next part. We have differentiated, right? So list our known and unknowns. Okay, so what do we know? What do we need? In this particular problem, we know that h is 4. And then what else do we know? For this solid, the diameter is 2, right? So if the diameter is 2, what's the radius going to be? Half of that, the radius is going to be 1. And something to note is that for this solid, the radius is constant. Okay, well, what does that mean? Well, we'll go over that in a second. So we know that the radius is diameter over 2, which is 2 over 2, so that's 1. Another thing we need, we can only have one unknown, okay? So just keep that in mind because we have one equation. We need to know the r dt. What is the r dt? Well, since the radius is constant, the r dt is the derivative of a constant. The r dt is equal to 0, okay? So let's put r is constant. R is constant. And then we need to know the h dt. So the h dt, so what we're looking at is the h dt when h is equal to 4, because h is already 4, okay? So let's look at what that is. Basically, the expression for the h dt is negative 1 over 10 root h. So we're going to, this is the h dt, we're going to evaluate this at h equals 4. So basically plug 4 into this equation right here, this expression. So we have negative 1 over 10 times root 4, which is equal to negative 2 over 10, which equals to negative 1 over 5. Okay? And then what is dv dt? dv dt is what we're looking for. Question mark. We don't know what that is. All right, so let's go ahead and set it up. dv dt evaluated at h equals 4 is going to be, now since the r dt is 0, what does that tell us? If this is 0, we multiply everything by 0, that's gone. So that part is gone. So we have 0 plus pi times r square, which is 1 square, the r dt, which is negative 1 over 5. And then when you simplify that, you're going to get negative pi over 5. What's the unit for this? Because we're asked to specify what the unit is. So let's look at what the left side of the equation is, and we can know what the unit is, okay? So we have dv dt. What is the unit of volume? Unit of volume and the unit of time in this particular problem. So let's go back up. The unit for side length is feet. So volume is the dimension of volume is length raised to the 3rd power. So it's going to be cubic feet. And then the dimension of time in this problem, I forgot what it is already. Let's go back. Seconds. So cubic feet per second is, so the unit for time is seconds. So the unit in this particular problem is negative pi over 5 cubic feet per second. That is the answer to question number 1. All right, so how was this question graded on the AP exam? Well, this particular question is a 2-pointer. You get 1 point for differentiating correctly. So ending up with dv dt equals pi r squared, you earn 1 point. And then you earn another point for getting your final answer with the units. Okay, if you don't have the units, it's not, you won't get the point. So for a total of 2 points in question number 4A of the 2019 AP Calc free response question. Alrighty, let's take a look at the B part. It says when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Explain your reasoning. So let's go ahead and see the tool in calculus that can help us to determine if the rate of change is increasing or decreasing. Okay? All right. So first things first, how do you know if a rate of change is increasing or decreasing, generally speaking? Let's take a look at that. So generally speaking, something that you want to note is as follows. The rate of change of the height is what? Is increasing when what? When its derivative, okay? So let's pause for a second. The rate of change is a derivative, okay? So when you're looking for the derivative of the rate of change of the height, it is the derivative of the derivative of the rate of is the derivative of the derivative of the height, or also known as the second derivative of the height, okay? So the rate of change of the height is increasing when its derivative, the second derivative of height, is positive, and decreasing when its derivative is negative. Okay. All right. So let's make a nice little matrix on the right here to help us see the connection. We're going to use the Hun chart for this. Okay. So let's say h is a height function, concave up, down. H prime is the rate of change of the height, basically what we're examining here to see if it's increasing or decreasing. So increasing, decreasing, increasing, decreasing. Okay. And then H prime is the rate of change of the height, positive, negative. All right. So if you take a look here, what we're focusing on is the behavior of the rate of change of the height. Okay, so we're going to know exactly where we are. Ladies and gentlemen, we are here. So what tells us if the rate of change of the height is increasing or decreasing? Well, the antiderivative is concave up or down, which we can't work on here. Or if if its derivative is positive or negative. Okay, so let's focus our attention will be focused right here. Bam. So what we're basically looking for is the sign of the second derivative of h. That will tell us if h prime, or the rate of change of h, is increasing or decreasing. Alrighty, so let's go ahead and write this down. What is our task? Our task is to find the sign. Find the sign of the derivative of the rate of change of the height. And we know from Navitt-Stiller that another word for rate of change is derivative. They're interchangeable. Okay? All right, so let's go ahead and see where are we starting from. Let's start from what we know. Okay? We know what the rate of change of the height is. The rate of change of the height, is given by dh dt. Okay? dh dt is equal to negative 1 over 10 root h. Now, what are we going to do with this rate of change? Well, we're going to find the derivative. We're going to find the rate of change of the height, or the second derivative. So its derivative is given by what? Its derivative is the second derivative of h, d squared h dt square. All right, so how do you find that? You just simply differentiate dh dt, negative 110 root h. You just simply differentiate that with respect to time. Ladies and gentlemen, this is another implicit differentiation, so you want to keep track of agreement. Okay? All right, so we're going to factor out the constant using the constant rule and differentiate root 10 with respect to time. Root h with respect to time. The derivative of root h is 1 over 2 root h. But since we have disagreement, we have to add on dh dt. Okay, so what did we just do here? Ladies and gentlemen, we differentiated implicitly. So this is implicit differentiation. Now, something that's very important is when you are finding higher order derivatives and implicit differentiation is involved, do not forget to resub your lower level derivatives into your higher order derivatives. What am I talking about? Ladies and gentlemen, we have the h dt here. We have to resub what the h dt is originally back into our second derivative. So basically d square h dt square is going to be negative, or we can make this look pretty, negative 1 over 20 root h. And then instead of the h dt, we're going to plug in what the h dt is right here. Let me color code it so we can see what's going on. Make it green. Negative 1 over 10 root h. You see that? So this is a consequence of resubstitution. So we are resubbing. You always want to resub when you find higher order derivatives during implicit differentiation. Okay, so what is it we're looking for again? Remember the task was to find the sign of the second derivative. That's the task. We're looking for the behavior of the derivative of h at h equals 3. Okay, so let's go ahead and see what the second derivative is at that value, namely h equals 3. But before we do that, let's see if we can make this look pretty. What do we have here? Oh, nice. These two h's divide out. So you have the square h dt square, the second derivative of height, equals, so minus minus is plus 1 over 200. What do we care about? The sign. So this is greater than 0. Okay, so let's go back to our Hunt chart right here. When the second derivative, or the rate of change of the height is positive, that means the rate of change of the height is increasing. Bam, there you go. Okay, so let's go ahead and put everything together in a nice little sentence in such a way that reflects that we are explaining our reasoning. Okay, so let's explain our reasoning. Since the second derivative, or the rate of change of the height, is equal to 1 over 200, which is positive, then the rate is always positive, okay? Then the rate of change of the height dh dt is doing what? Is increasing when the height is 3. When the height is 3 feet. All right, so ladies and gentlemen, there goes your answer to question number 4B. All right, so how was it scored on the AP exam? This was a 3-pointer. You get the first point for setting up a scenario where you're considering the derivative of the h dt. So you get 1 point right here. You get another point for accurately differentiating. So the setup is 1. Differentiating implicitly correctly will give you another point. And then your final answer with explanation, this entire piece right here, will give you another point. Ladies and gentlemen, you get a total of 3 points for this question. All right, in question number 4C, we're going to be assessed on how to solve differential equations. All right, so it reads, at time t equals 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. Okay, so when you're given a differential equation, for example, let's say you're given dk dt is equal to something, okay, and you're asked to find an expression for k, what you're doing is you're solving the differential equation. Okay, so given a differential equation, let's go ahead and write down the differential equation here. So the differential equation under consideration, ladies and gentlemen, is dh dt equals negative 1 over 10 root h. So if they give you an equation involving differentiation and he has to isolate or find the dependent variable, it could be y or whatever is in the numerator on the left side, you're solving a differential equation. That's what you're doing. Okay, all right, so let's go ahead and talk about the procedure for solving differential equations. Okay, so let's also outline the procedure. So the procedure is psi phi I. Okay, so that's what you do. So number one, you separate the variables. Number two, you integrate both sides of your equation. Step 3, you find the constant resulting from your indefinite integration. Number 4 and 5 are kind of connected. You're going to insert C, and then part 5, you isolate y. That's the IY of psi phi I, okay? Isolate y. In this particular case, we're looking for h, so we're going to be isolating not y. The dependent variable in this problem is h, so we're going to isolate h. Okay, so there goes the steps for solving differential equations. Okay, let's get started with part 1. Step number 1, we are going to separate the variables. All right, so something to keep in mind is that on the AP exam, whenever you have a differential equations problem, you're asked to solve it, it normally carries a lot of points. In this particular year, it carried 4 points. That's a lot. Okay, all right, more than almost 50%. So to separate, what are we separating? The dependent variable on the left side, so f of h and dh will be on the left. How do we know that? Well, for a differential equation, as I indicated, the dependent variable is h. dh is on the numerator on the left, so that's what you use, okay? So h's will be on the left side, so f of h and the h will be on the left, and then what's on the right? dt and f of t, okay? So f of t and dt will be on the right. When we achieve this state, we have separated the variables. Okay, let's do it. So we have dh dt is equal to negative 1 over 10 root h. So let's move dt to the left side first, and then we're gonna move dh and f of h to the left. I'm sorry, dt to the right and f of h and dh to the right. Okay, so to get dt to the right side, we're gonna multiply both sides by dt, like that. So that divides out. So we have dh equals negative 1 over 10 root h dt. and then we want root h to the left side. So what we'll do is we'll multiply both sides by 1 over root h, like that, and like that. Bam. So you see how on the right side, this h's divide out. Leave the constant on the right, okay? You don't want anything making a mess on the left side. You just want the function of the variable of the dependent variable on the left. If you have constants, put them on the right side. Okay, so we have it right here. So let's make it look pretty. We have 1 over root h dh is equal to negative 1 over 10 dt. The variables have been separated. Okay, we're going to be integrating next, but let's get it prepped for integration. 1 over root h, how do you integrate that? There's no rule for that. How about I rewrite? Okay, we know in Roper, one of the first steps is one of the ways to integrate. We have rewrite, area, use sub, power, and reversal. So let's rewrite this as a power. So when we rewrite this as a power, then it's a piece of cake to integrate using the power rule. So we're getting it prepped for integration, which is step number 2. All right, so let's advance to step 2. We're going to integrate both sides to get rid of these infinitesimals that we have here, the h and the t namely. So 2, we are going to integrate to get rid of the h and dt. Okay, so let's rewrite the equation. We have h to the negative 1/2 dh is equal to negative 1 over 10 dt. So let's go ahead and integrate both sides of our equation. On the left side, we're integrating with respect to h, and on the right side, with respect to t. All right, so when we apply the power rule on the left side, we are going to have h raised to the negative 1/2 plus 1, which is 2 over 2, okay, divided by negative 1/2 plus 2 over 2. And then on the right side, the integral is just going to be negative 1 over 10 t, okay, plus, don't forget that c piece right there, plus c. All right, let's make it look pretty. On the left side, we have h to the 1/2 over 1/2 is equal to negative 1 over 10 t plus c. And then we can drop change flip. And then we have 2 times root h equals negative 1 over 10 t plus c. Okay? So what we have now, this, ladies and gentlemen, is known as the general implicit solution. Let's just put a side note here. This is known as a general implicit solution. What's cool about this? Well, this is the solution that you want to use to find C. This is a state that you want to find C. If I isolate H here, it will give us the general explicit solution. In this problem, we're looking for the particular explicit solution. So we're not there yet. All right, so let's move on to part 3. For part 3, we're going to be looking at determining what this C value is. So let's write that down. So 3, we're going to find C using the initial condition. What initial condition were we given here? We were told that, what were we told? I don't remember. It says at t equals 0, the height is 5. Excellent, that's what we want. So using the initial condition, h of 0 equals 5. Sometimes the initial condition is presented in an ordered pair. So like 0, 5, it's the same thing. All you just need to know is what is your dependent. Our dependent is t. And what is our independent? Our independent is t and our dependent is h. Okay? So we're just going to substitute 0 for our independent t and then 5 for our dependent h. And we are in business. And solve and find c. Let's do it. So let's rewrite the equation that we had before. Okay, so it was 2 root h is equal to negative 1 over 10 t plus c. Okay, so let's plug it in. We have 2 root 5 is equal to negative 1 over 10 times 0 plus c. Okay, oh, this is 0, so we simply have c. Our c value is 2 root 5. Bam. Okay, now the last, to finish it off, step 4 and 5 together, we are going to IIH this problem. What am I talking about? We're going to insert c into our general implicit solution here. Okay, insert c into 2. All right, and isolate. The procedure say isolate y, but in this case we're going to isolate h. Okay, and then when h is isolated, ladies and gentlemen, we have achieved the solved state. Okay, so let's do it. The general implicit solution was 2 root h equals negative 1 over 10 t plus c. Oh, we know what c is. C is 2 root 5, so we have the substitution now. So we just inserted c into the general implicit solution. This is the particular implicit solution, but we need to find the particular explicit solution. Okay, so it's explicit when you have h isolated. So how do we do it? Just divide by 2 and square. End of story. Okay, let's do it. So since we have fractions on this side, let's do it this way. What we're going to do, ladies and gentlemen, is multiply both sides of our equation by 1/2, which is equivalent to dividing by 2, multiplying by its reciprocal. So these 2's divide out, so we have root h is equal to negative 1 over 20 t plus root 5. Okay, and then to get h isolated, the last step, we're simply going to raise both sides to the second power. That's the inverse of square root. Raise this to the second power, raise this to the second power, and then you have your final answer. H is equal to the quantity negative 1 over 20 t plus root 5. Now this is a question of plus root 5 square. Now this is a question I have for you. Can I say that this simplifies into 1 over 400 t plus 5? Is that right? No, that's wrong, 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 wrong. If you want to expand this, which is unnecessary, you will have to FOIL it out. Okay, you have to remember your formula from algebra, which is that a plus b quantity square, there's going to be a square, and there's a middle term, plus 2ab plus b square. It's not a square plus b square. That's wrong. Okay, please don't do that. All right, so just set it up like this. You don't want to waste your time losing points trying to do arithmetic simplification. Just set it up like this, and ladies and gentlemen, there you go. Okay, so as indicated earlier, this is a 4-pointer. Let's go ahead and go over how you earn your 4 points in this question on the AP exam, okay? First point you earn by separating your variables. Right here, you earn 1 point here by separating variables. And then when you integrate correctly to get your general implicit solution, that's another point. When you use your general implicit solution, when you use your general implicit solution and your initial condition to find C, that's another point. And then lastly, when you insert C into your general implicit solution and have H isolated, you earn your last point. Okay. Something to keep in mind is that if you forget this C, you will automatically lose 50% of the points. You cannot get more than 2 points if you forget C. So bottom line is, don't forget your C anytime you are integrating indefinitely, okay? All right, so let's write down the total here. For this one, you get 1 plus 1 plus 1 plus 1, total of 4 points, and that's a lot of points for a question part on the AP Calc AB exam. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming AP Calc exam, do give us a thumbs up. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel. If you have any questions about what we covered in this presentation or any calculus questions in general, just place your questions in the comment section below and we'll be more than glad to support you. Tons of support resources can be found at our website, mathgotserved.com, or just take a look at the links in the description below. Thanks again for watching and have a wonderful day. Goodbye.